We experience life as a single fleeting moment. The past is a memory, the future is a blank slate, and only the now actually exists. Philosophers call this deeply intuitive feeling presentism, the idea that time acts like a moving spotlight, illuminating just one sliver of reality as it pushes constantly forward. When Albert Einstein published his theory of general relativity, he proved that time is flexible. It can stretch and warp depending on how fast you're moving or how close you are to a massive object. But even in Einstein's relative universe, that spotlight still marched strictly in one direction, forward. That changed in 1949. Einstein's close friend, the brilliant mathematician Kurt Gödel, discovered an exact, valid solution hidden inside Einstein's own field equations that dismantled the concept of linear time. Gödel proposed a mathematical model of the cosmos, bypassing the mechanical constraints of spinning dials and metal gears usually associated with time travel. Because his theoretical universe plays by the exact same physical rules as ours, it exposed a loophole in the nature of reality. If time could behave this way in a universe built on our physics, our everyday understanding of a flowing, one-way clock was suddenly in jeopardy. This theoretical cosmos is known as the Gödel metric. It describes a universe filled with a completely even distribution of swirling dust grains, balanced out by a highly specific negative cosmological constant. The defining physical characteristic is that the entire cosmos is engaged in extreme perpetual rotation. Every particle of matter swirls in a continuous, unending spin. To see how this spin affects time, imagine a 3D diagram called a light cone. The horizontal plane is physical space, and the vertical axis is time. The cone represents all possible future paths. In a standard universe, these point straight upward. You can move horizontally through space, but you are always pushed strictly upward along the time axis, enforcing cause and effect. In the Gödel metric, that mechanism is the rotating universe itself. The swirling dust creates an effect called frame dragging. The rotation physically grips the fabric of spacetime and drags it along for the ride. As you move outward into this swirling mass, the dragging effect severely warps the local geometry. The light cones lean and widen in the direction of the spin, approaching a specific mathematical limit. At a critical radius, the warping becomes extreme. The cone tips over completely, dipping below the horizontal spatial plane. A trajectory moving forward in space now points downward on the vertical axis. You are literally traveling backward in time. Physicists call this a closed time-like curve, or CTC. It creates a causal loop where a sequence of events can intersect its own origin, allowing an object to exist in its own causal past. The physical mechanic is simple to visualize. If a traveler hops in a spaceship and flies in a wide enough physical circle through this warped region of space, following the rotation, they will naturally be deposited at an earlier point in time. By proving mathematically that light cones can tip over, Gödel turned time travel from science fiction magic into a valid, rigorously calculated outcome within the equations of general relativity. This creates a profound philosophical trap. If it is possible for a traveler to navigate a closed time-like curve and visit yesterday, it means yesterday must still be there to visit. The past cannot have ceased to exist. This points toward a concept called eternalism, often referred to as the block universe. It stands in direct opposition to presentism, suggesting instead that the past, the present, and the future all exist simultaneously. Under this framework, the distinction between earlier and later is subjective. Every event, your birth, the moment you are experiencing right now, and your distant future, are simply fixed coordinates locked within a static map of spacetime. Modern astronomical observations confirm that our actual universe is expanding, not rotating. We do not live in the exact conditions of the Gödel metric, which means we cannot physically build this specific type of time machine. But Gödel anticipated this. His insight relied on the math itself. If the exact same field equations that govern our reality also allow for a geometric universe where the past and future exist simultaneously, then the forward passage of time is not an absolute physical requirement. He used Einstein's own mathematics to show that the flowing, linear experience of time we feel every day is not an objective property of the cosmos. It is merely a biological illusion.